27. A drawing of an object has a scale where a length of 4 inches on the drawing represents an actual length of 9 feet. So we have a ratio, 4 inches to 9 feet. That's our fixed proportion. We're going to set up a proportion equation here. The actual length of the object is 12y feet. So that would be 12y feet, which means our unknown length in inches for the object in the drawing is going to be, call it x inches. Now we've got a proportion equation I will just solve. By the way, before I even do this, I could notice that 4 to 9 is a little less than half the numerical value. So if I have 12y feet, I'm going to have something a little less than 6y feet, 6y inches as my answer. The only number that's close to 6y inches looks to be C. So I think that on a quick estimate is going to be the answer. In fact, there's nothing else in that ballpark, so I know it's going to be the answer. So estimation is one way you can quickly get to the answer. Now, let's continue with the algebra and solving our proportion equation. So I'll cross multiply here. Actually, really, I'll just multiply by 12y on both sides to get rid of the denominator on the right side. 12y's cancel. X equals 12y times 4 over 9. Well, 12 over 9 reduced to 4 over 3. X equals 4 times 4, which is 16y over 3. Sure enough, that is answer C, 16/3 y. The correct answer for 27 is C. We've got a couple different approaches we can take to get there. 28. So I've got two data sets. Right away, I can see we're going to play with the mean, median, standard deviations of the two of them for the dot plots. The dot plot shown represents the data set. The following statement best compares the means and the standard deviations of the two data sets. Okay, both data sets are symmetrical around the middle value, 20, which means the mean equals the median when that happens. So my mean is going to be the middle value. It's going to be 20 for both data sets. The means are equal. So let's quick look through the answers. The means are equal. That could be A. The means are equal. That could be B. The mean of data set A is less. That's not right. C. The mean of the data set A is greater. That's not right. The means will be equal. Now, how about the standard deviation? Standard deviation is a measurement that assesses how far the data is from that middle or expected value. So we can see the data is more bunched up in the middle for set A, whereas that data is distributed outward more in data set B. So these points here will add to the standard deviation, whereas here it's not going to add to the standard deviation much for set A. So data set B has a greater standard deviation. So standard deviation we can denote by the sigma symbol for B is going to be greater than the standard deviation or sigma of A. So let's check A and B, which says that. The means are equal. A says the standard deviation of A is less than the standard deviation of data set B. That's correct. That's the answer. B says the standard deviation of data set A is greater than the standard deviation of data set B. That is not correct. The data is bunched up more around the middle. Correct answer for 28 is A.